Hello students, today we are going to continue the problems regarding pseudo force. Now this is a system, a spring and blocks are connected here. It is moving upwards with the acceleration a naught as shown in the figure, and the question here is find the extension in the spring. Extension, how much it extended. Now the solution is, so if you try to solve, this can be solved in a inertial and non-inertial frame of reference. In the both cases it can be solved. If you take frame of reference as a moving body, the problem becomes easier to solve. Okay, now I am considering frame of reference as elevator. That means we are sitting here. If we are sitting here, now I am observing block M2. What are the forces acting on the block M2? Upward force, there is a tension. On the downward force, there is M2G. And because we are taking a reference as a elevator, how much accelerated elevator is moving? A naught. The pseudo force will be M2 times A naught in the downward direction. Why? A naught is in the upward direction, pseudo force act in the downward direction. Next, now with respect to the frame of reference, now it is moving say upward with the acceleration A1. Okay, and it moves with the upward acceleration, it goes down with the acceleration A. Okay, now T A in the it's upward direction as we considered. T minus M2G plus A naught is equal to M2 multiplied with A. Next, we will consider the next free body diagram of M1. This is M1 T and the downward force M1G. If so, you may get the question that, sir, will it be accelerating or not? Acceleration is equal to 0, na? No, it's not equal to 0. Now when we see the pulley and blocks diagram, M1, M2, when they are in the ground, they, even if and only if M1 is equal to M2, they don't have acceleration. It is like the elevator becomes a ground for us if we consider frame of reference. So don't have to worry about the other part. It is A and T, and which direction it is? Pseudo force. In which direction pseudo force will act? It is acting in the downward direction. It is M2 into A naught. Acceleration is in the downward direction. Acceleration in the downward direction. Write the equation. M1, it's not M2, M1 into A plus A naught plus G minus T is equal to M1A, equation 1 and 2. If we add these two equations, M1 minus M2 into A naught plus G is equal to M1 plus M2 into A. A is equal to M1 minus M2 over M1 plus M2 multiplied with A naught plus G. Then the tension is equal to, what is the tension? Tension is equal to M2A. M2 into A, M1 minus M2 over M1 plus M2 into A naught plus G, and this the M2G plus A naught goes to other side, becomes plus, it goes to other side, becomes plus M2 A naught plus G. If we add these two, we will get an answer to M1 M2 over M1 plus M2 into A naught plus G. This is the tension. Now the question asked was, go through the question once. what is the extension in the spring? If you draw the diagram carefully, there is a spring here, there are two tensions T and T. Spring upward force is spring force, just write Fs. The pulley is massless, M is equal to 0, then Fs is equal to 2T. Okay, Fs is equal to K into X is equal to 2T, X is equal to 2T over K. If you want to write 4 M1 M2 into A0 plus G by K into M1 plus M2. This is the answer for this question. Let's see another question. Now look at this diagram carefully. There are three blocks on it, one over another. Okay, a figure shows the large block of mass M supporting two small blocks M1 and M2. A force F is acting on M such that the blocks M1 is sliding down with acceleration A relative to M. It is sliding down. Remember in which direction it is sliding? Sliding down. Find the force F applied on the mass M and also acceleration of M. Okay. To solve this, first let's draw. I am assuming what frame of reference is given relative to this point is important, relative to M. I am considering all the three blocks as single block. I am assuming all as single system. If I assume single system, what will happen to the tensions? Tensions gets cancelled, only upward and downward forces will be there, are of no use. M plus M1 plus M2, total 3 masses, and there is a force F. Let's take the acceleration as E. It's on a frictionless surface. A is equal to F over M plus M1 plus M2. Okay, we got acceleration. Acceleration of whom? Acceleration of three blocks in which direction? Horizontal direction. Listen carefully. Now this capital M move in which direction? In the right direction. With what acceleration? A acceleration it moves. Now I am going to consider the M as a relative or frame of reference. If I consider M as a frame of reference, now I am going to draw free body diagram of M1. This is M1. Let me see the question again. M1, this is M2. This is M2, and that there is a tension force. What is our frame of reference? Our frame of reference is capital M, and it is moving with the acceleration. How much acceleration it moves? So it is moving in the downward direction, capital A, M1, and how much acceleration? M2 also move. M2 also move with the acceleration A in this direction. Okay, what is other force acting? Is there any pseudo force? Yes or no? Yes, there is a pseudo force, because the capital M is moving in capital A in the right direction. It exerts force. What is the pseudo force value? M2 into capital A. And if we write equation T minus M2 into A is equal to small m2 into A. This is the first expression. Then see the other block M1. If you consider other block M1, what are the forces acting on it? Upward force is tension T, downward force is M1G, and in this direction, what is the force acting? Force acting is equal to, because the frame of reference, again the block is here, it is frame of reference is A, and it pseudo force acting in the backward direction, M1 into A, and there is a normal because in contact with this there is a normal also. Now how much acceleration it is moving downwards? A. m1 into g minus t is equal to m1 into a, equation 2. Now let's solve equation 1 and equation 2. If we add equation 1 and 2, we will get directly answer m1g minus m2 into a is equal to m1 plus m2 into a. What is a? m1g minus m1 plus m2 is equal to m2 into a. What is a? A is equal to f over m1 f over m into m1 plus m2. Send it to other side. F is equal to m1 m2 over m1 plus m2 plus capital M into G minus m1 plus m2 by m2. There will be small a, capital M plus m1 plus, oh I did a mistake, wait, I am taking this m total mass, m total, okay, to write it as simple as possible. m1 by m2 into g multiplied with m total minus m1 plus m2 into a over m2 into m total. This much force is required to move the capital M.